All right, so this is 2.5 part 2. So we saw this slide on the notes from Friday. It talks about the fundamental theorem of algebra. So that just says that if I have something like x to the 5th power, I'm going to have 5 zeros. So there's going to be 5 answers to whatever my polynomial is. Some of them may be real, some may be imaginary, but there will be 5 total. So if we have a complex zero, so complex meaning that it is an imaginary number or a square root, complex zeros occur in conjugate pairs. So if I have a plus bi, a minus bi will also be a zero of the function. So if I had something like positive 2i as a zero, I would also have negative 2i as a zero. Same thing if I had a square root. If I had square root 5 as a zero, I would also have negative square root 5 as a zero. So complex zeros occur in conjugate pairs. Another example would be, let's say I had 2 plus 3i. What's the conjugate pair of this? 2 minus 3i. So the 2 stays the same, but the imaginary part is what changes the sign. So we are going to find a 4th degree polynomial function with real coefficients that has -1, -1, and 3i as zeros. If it's a 4th degree polynomial, how many zeros am I going to have? 4. So I should have 4 zeros total. So which is the zero that I'm missing from my list here? I have 3. Negative 3i. So since 3i was a complex zero, the conjugate is also a zero. So to find the polynomial, we're going to plug these in to factored form. So we've done this before. It's like working backwards, and then we have to FOIL it out. We did this in one of our earlier sections. We just didn't quiz on it, so we're going to be quizzing on it now. So in my parentheses, what do you think I'm going to put? Awesome. X plus 1, x plus 1, x minus 3i, and x plus 3i. So we always change the signs, because when you plug it in, it's like saying x minus -1, which turns into a plus. So always change the signs of the zeros that you plug in. Now, how can I find my polynomial function? I have to FOIL it out. So I always want to start with any complex pairs that I have. The conjugates. Because I have a shortcut to multiply conjugates together. So I'm going to do it on the side just because there's kind of 2 different ways that we could do this. If I had something like a minus bi times a plus bi. When you have imaginary numbers, we can FOIL this out and we will get a squared plus b squared. So b being just the number in front of the I. If they were conjugates but not complex conjugates, so not imaginary numbers, it would be a squared minus bi squared. So doing it this way is kind of just like the shorter cut way of this, because we would change the I squared to -1 and make it a plus. This should be squared because the b will be squared also. So there's 2 different ways of multiplying our conjugates together. When we have something other than i's, it's going to be a squared minus bi squared, like that. So it'll be the first term minus the second term. So the only reason why we did a plus before is because we already accounted for the I squared in there. But when we multiply conjugates, it should be minus in the middle. So here, when I FOIL these out, or when I do my shortcut, I have x squared minus 3i squared. So I have to square the 3 and square the I. So it would be 9i squared. And what does I squared turn into? -1. So it's x squared plus 9. All right, next I'm going to multiply x plus 1 times x plus 1. So these are not conjugates, so I actually have to FOIL them out. So I start by multiplying the first, the outer, a squared minus b squared when it's not imaginary. So for some of these examples, we will have something like x plus square root 5 times x minus square root 5. So this would be x squared minus square root 5 squared. So it's always minus in the middle. So that's why I wanted to show you guys that, just so we don't get confused. When we have an I, we can just say plus, but just always do minus, and then you could always change the I squared to make it a plus. All right, back to FOILing this out. So first, outer, inner, last, plus 1. So when I simplify this, it becomes x squared plus 2x plus 1. So then the last step is I have to multiply these two guys together. So this x squared plus 2x plus 1 was the product of x plus 1 times x plus 1, and then the x squared plus 9 was the product of our conjugates there. Then the last step is to multiply these together. So it's just like FOILing, but the first one has 3 terms, so we just have to make sure all 3 terms get multiplied to both terms in the second parentheses. So I'm going to start with x squared. So x squared times x squared would be what? X to the 4th power. Then x squared times 9. 9x squared. Then I have 2x times x squared. 2x cubed. Then 2x times 9. 18x. And then 1 times x squared. X squared, and 1 times 9, 9. And then from here, what can I do? Combine like terms. So I can start with my x to the 4th power. Then I have an x cubed, so plus 2x cubed. Then I have 2x squared, so I have 9x squared plus x squared, which would be what? 10x squared. And then plus 18x plus 9. And then our polynomial, we always like to name it with an f of x is equal to this. Whatever your highest degree, so here it's a 4, x to the 4th power, that's how many zeros we started with. So it'll always match up. If it doesn't, you probably did something wrong. All right, so let's look at number 1. How would I set up my factors here? X plus 5? Just x and x minus 2. Perfect. If 0 is one of your zeros, it's just x, because you wouldn't say x plus 0. So then to multiply this one out, what should I do? I'm going to FOIL. I'm going to start with these two first and FOIL them out. So x times x would be x squared minus 2x plus 5x minus 10. I'm going to combine my like terms. So x squared plus 3x minus 10. And then I still have that x on the outside, so what should I do next? Distribute. So this becomes x cubed plus 3x squared minus 10x. I just distribute that x to everything on the inside. And once I'm done, just make sure you name it with an f of x. All right, we're going to do one more of these. So let's look at number 3. So here I have an imaginary number. Am I missing any zeros? What? Negative 2i. So if I have a complex number, whether it's imaginary or a square root, I also need the conjugate pair. So when I plug these into my factored form, what would I put? Perfect. X plus 1, x plus 2i, and x minus 2i. So what do I want to start multiplying out? The conjugates here. So I'm going to start with the complex ones. Because when you have the conjugate, you'll end up with a shorter answer. So I start with x squared minus 2i squared. So that squared gets distributed to the 2 and the I, so it'll be 2 squared, which is 4, and I squared. What does I squared turn into? A negative 1, so it makes it a plus. So this is x squared plus 4. What's next? Awesome, I got to multiply x plus 1 to that. And then from here I can just FOIL. So start with the first. So x cubed. The outer would be 4x. The inner is plus x squared. And then the last plus 4. Can I leave my answer like this? What's wrong with it? Not in standard form. So I'm going to start with x cubed plus x squared plus 4x plus 4. And then that is equal to f of x. But let's just take a look at them real quick. From number 2, am I missing any zeros? What? Awesome. Negative square root 3. From number 4, am I missing any zeros? What? Awesome. Negative 3i and 2 minus I. Perfect. So we're going to come back to these two tomorrow. All right, so looking at number 2, what am I going to put in the parentheses? X plus 5. What else? X minus square root 3 and x plus square root 3. So I'm going to start by multiplying my conjugates together. So my conjugate shortcut is the first term squared minus the second term squared. So this would be x squared minus square root 3 squared. What is square root 3 squared? Just 3, because the square root and the squared cancel. So x squared minus 3. Now this I just have to multiply by x plus 5. So I'm just going to FOIL these together. So start by multiplying the first. X times x squared would be x cubed. X times negative 3 is negative 3x. 5 times x squared is 5x squared. And 5 times negative 3 is negative 15. I'm going to put it in standard form. So x cubed plus 5x squared minus 3x minus 15. And then what else do I need? F of x. On the answer key to the review, it has it equal to 0. If you put either one, that's fine. You could either set it equal to 0 or equal to f of x. Just make sure it's an equation, not just the x's there. So I'm going to write my pairs together. So I'm going to start with the x plus 4. Then I have 3i and minus 3i. So this will be x plus 3i, x minus 3i. And then I have x minus 2 plus I. and x minus 2 minus I. So we start by multiplying our conjugate pairs. So I'm going to multiply the x plus 3i and x minus 3i first. So my shortcut is to square the first term minus the second term squared. So the 3 gets squared and the I gets squared. So this is x squared minus 9i squared. What does the I squared turn into? A negative 1, which makes it a plus 9. So this is x squared plus 9. Now I'm going to multiply my second conjugate pair, these two. What do I have to do first? Distribute the negative. So this is x minus 2 minus I and x minus 2 plus I. So here I have conjugate pairs again. My first term is x minus 2 and my second term is just I. So I have x minus 2 squared minus I squared. So what do I have to do x minus 2 squared? Foil it out. So this is like saying x minus 2 times x minus 2. And we FOIL. So I have x squared minus 2x minus 2x plus 4. So this would be x squared minus 4x plus 4, because I just combined my like terms. And then I still have that minus I squared. What does the I squared turn into? A negative 1. So this would be a negative 1, which turns into what? A plus 1. So this would be plus 1. And then I can combine my like terms here. So that would be x squared minus 4x plus 5. So then I still have this x plus 4 to multiply. I don't know if there's like a best way of what to do next. I could just multiply these two together and then multiply it by the third one here. So let's do that. We have x plus 4 times x squared plus 9. So we're going to FOIL here. I have x to the third power plus 9x plus 4x squared plus 36. So this is x to the third power plus 4x squared plus 9x plus 36. So now we have to multiply both of these. So we still FOIL, but it's heavy duty foiling here. Just make sure everything in your first parentheses gets multiplied to everything in the second. So if I start with x cubed, I have x cubed times x squared, which would be x to the fifth power. Then x cubed times negative 4x would be negative 4x to the fourth power. And then x cubed times 5 would be 5x cubed. Next, I can move on to the 4x squared. So 4x squared times x squared would be 4x to the fourth power. 4x squared times negative 4x would be negative 16x cubed. 4x squared times 5 would be plus 20x squared. Then I can move on to the third term. So 9x times x squared would be 9x cubed. 9x times negative 4x would be negative 36x squared. Yeah, negative 36x squared. And 9x times 5 would be 45x. And then I have 36. So 36 times x squared would be 36x squared. 36 times negative 4x would be 144, negative 144 x. And then 36 times 5. So plus 180. And then I just combine all my like terms, all of them. So I start with the x to the 5th power. And then I have negative 4x to the 4th power plus 4x to the 4th power, which those will cancel. That's nice. And then I can move on to my x cubes. So I have plus 5x cubed minus 16x cubed and plus 9x cubed. So that would be negative 2x cubed. Yep. Then I can move on to my x squareds. So 20x squared minus 36x squared and plus 36x squared. So the 36's will cancel. So this is just plus 20x squared. Then my x's, I have 45x and negative 144x. That would be negative 99x. And then just plus 180. And that's my answer. Yes, f of x equals. All right, next we're going to look at example 7. So here it gives us the polynomial, and we have to find all the zeros, and it gave us one of them. If I have 1 plus 3i is a 0, what's another 0 that I know? 1 minus 3i. So if I plugged these two into my factored form, I would have x minus 1 plus 3i and x minus 1 minus 3i. So remember, it's always x minus your 0. So these were my two zeros, and I plugged them into the factored form. What do you think I need to do next to multiply these out? I want to distribute the negative on the inside. So this is x minus 1 minus 3i and x minus 1 plus 3i. Now here, because I have 3 terms inside each parentheses, they may not look like conjugates, but they actually are. I have x minus 1 as my first term, and then 3i as my second term. Because I have a x minus 1 minus 3i and x minus 1 plus 3i. So these are conjugates. So that means I can do my conjugate shortcut. So I can say my first term, so x minus 1 squared, minus my second term, 3i squared. How do I do x minus 1 squared? I have to FOIL it. So if it helps, rewrite it twice. I have x minus 1 times x minus 1 and FOIL it out. This gives us x squared minus x plus 1. And then for the second term here, I have to distribute the squared. So it would be minus 9i squared. And what does the I squared turn into? A negative 1 to make that a plus 9. Now what can I do next? Combine like terms. So I have x squared minus 2x plus 10. So this guy here is a factor of the polynomial that I started with. How do you think I could find other factors? Long division. Yes. So we're going to do long division. So x squared minus 2x plus 10 goes on the outside, and then that whole polynomial goes on the inside. Oh my goodness. So x to the fourth power minus 3x cubed plus 6x squared plus 2x minus 60. So here we have to do long division because we have a trinomial that we're dividing, so we would not be able to use synthetic division. Has to be long division. So to do long division, I start by dividing. So I divide my first term by the first term on the outside. So what's x to the fourth power divided by x squared? X squared. So that's going to go on top of the x squared term. So then once I write it on top, I multiply by everything on the outside. So x squared times x squared would be x to the fourth power. X squared times negative 2x would be negative 2x cubed. And x squared times 10 would be plus 10x squared. What do I have to do next? Change the sign. So I change the sign of this whole row and combine. So the x to the fourth powers cancel. Then I have negative 3x cubed plus 2x cubed, which would be negative x cubed. And then 6x squared minus 10x squared would be negative 4x squared. And then we do it again. Divide. So negative x cubed divided by x squared would be what? Negative x, perfect. Then I multiply. Negative x times everything on the outside. So negative x cubed plus 2x squared minus 10x. What's next? And what else? Change the sign. So I change the sign of everything in this row. So it becomes a plus x cubed minus 2x squared and a plus 10x. And then we combine. So the x cubes cancel. This becomes negative 6x squared and then plus 12x. What do I do next? So divide negative 6x squared by x squared, which is negative 6. Then I multiply negative 6 times everything on the outside. So negative 6 times x squared would be negative 6x squared. Negative 6 times negative 2x would be plus 12x. And negative 6 times 10 would be negative 60. Change the signs. Drop down this negative 60 on top and combine. So these all cancel. So I have no remainder. You will always get no remainder at this point because what you're dividing in is a factor, so it'll go in evenly. So if you get a remainder here, you did something wrong. So you always get no remainder here. So now I know that x squared minus x minus 6 is a factor. So how could I find the zeros? Set it equal to 0 and factor it. What are two factors of negative 6 that add to negative 1? Negative 3 and positive 2. So x minus 3 and x plus 2. Set them both equal to 0. So x is equal to 3 and x is equal to negative 2. So all of my zeros from all of this work that I just did are x is equal to 3, negative 2, and then the 2 that I started with, which is 1 plus 3i and 1 minus 3i. So my question started with x to the 4th power, so that told me I was going to have 4 zeros. And in my answer, I have 1, 2, 3, 4. 4 zeros. If 3 plus 2i is a factor, what's another factor that I'm going to have? 3 minus 2i. So I'm going to plug that into my factored form. So I have x minus 3 plus 2i and x minus 3 minus 2i. What do I have to do next? Distribute the negative. So this is x minus 3 minus 2i and x minus 3 plus 2i. Now here we will always have conjugates. My first term is x minus 3 and my second term is 2i. So what's the shortcut to FOIL these out? X minus 3 squared minus 2i squared. So we can start by multiplying out that x minus 3 squared. So here we cannot just distribute the squared, we have to FOIL it. So this is like saying x minus 3 times x minus 3. If you need to, write it twice right next to each other, FOIL it out. So x times x would be x squared. X times negative 3 is negative 3x, negative 3x, and negative 3 times negative 3 is positive 9. And then here I can distribute the squared. So this would be minus 4i squared. And what does the I squared turn into? A negative 1. So that becomes a plus 4. What can I do next? Combine like terms. So x squared minus 6x plus 13. So this is a factor of the original x cubed minus 11x squared plus 43x minus 65. How can I find another factor? Long division. So I start with x squared minus 6x plus 13 on the outside, and then my polynomial goes on the inside. So x cubed minus 11x squared plus 43x minus 65. So long division, how would I start? Divide x cubed by x squared, and I would get x. Once I write it on top, then what do? Multiply by everything on the outside. So x times x squared would be x cubed. X times negative 6x is negative 6x squared, and x times 13 is 13x. Yeah. What would I do next? Change the sign and combine. So all of these, we change the sign. So the x cubes cancel. Negative 11x squared plus 6x squared would be negative 5x squared. 43x minus 14x would be 30x. And then we start from the top. Divide by x squared. So that gives us negative 5. Once you write it up top, multiply everything on the outside. So negative 5 times x squared would be negative 5x squared. Negative 5 times negative 6 would be plus 30x. And negative 5 times 13 would be negative 65. What's next? Bring down the negative 65 and change the sign. So this becomes a plus, minus, and plus. So the 5x squareds cancel, 30x's cancel, and 65's cancel. you will always end up with no remainder because what you're dividing is a factor. So if you have a remainder, you either multiplied wrong or you long divided wrong. So x minus 5 is a factor. So how would I find the missing 0? Equal it to 0. So my other 0 is x is equal to 5. So I have x is equal to 5, 3 plus 2i, and 3 minus 2i. On WebAssign, it says list all the zeros, and I think it specifically says even the included one, or even the one that was given. So when you put it into WebAssign, you would probably put it like this. I think it wants it in the commas too. So for these types, it gives us a 0, and we have to find the rest of them. So if I have negative 2 minus 5i is one of my zeros, what's another one?
Negative 2 plus 5i.
Awesome, negative 2 plus 5i. All right, so we want to put this into factored form. So I have x minus negative 2 minus 5i and x minus negative 2 plus 5i. So when I'm multiplying all of this out, what should I do first? Distribute the negative. So x plus 2 plus 5i and x plus 2 minus 5i. So these are conjugates. My first term is that x plus 2, and my second term is the 5i. So when I FOIL these out, my shortcut is my first term squared, so x plus 2 squared minus 5i squared. So when I have x plus 2 squared, how can I multiply that? What should I do there? I have to FOIL it. So it's x plus 2 times x plus 2, and I FOIL it out. So this would be x squared plus 2x plus 2x plus 4. And then when I have 5i squared, I have to square the 5 and square the I. So this would be minus 25i squared. And what does I squared turn into? Negative 1, so that becomes a plus 25. And then the last step here is we can combine our like terms. So I have x squared plus 4x plus 29. So this is a factor of the polynomial that was given. How can I find the remaining 0? Long division. So x squared plus 4x plus 29 goes on the outside. And then x cubed plus 11x squared plus 57x plus 203 goes on the inside. So we start by dividing. X cubed divided by x squared would be what? X. So I put that x on top. Then I multiply. So x times everything outside would be x cubed plus 4x squared plus 29x. What's next? Change a sign, change a sign, change a sign, and combine them all. So the first ones cancel. 11x squared minus 4x squared would be 7x squared. 57x minus 29x would be 28. So plus 28x. What's next? So we divide again. 7x squared divided by x squared would be 7. So 7 goes on top, and then we multiply times everything on the outside. So 7 times x squared would be 7x squared. 7 times 4x would be 28x. And 7 times 29, I'm going to guess and say it's 203. What do I do next? Change the sign. So change the sign, change the sign, change the sign, and combine them all. They all cancel, so we're left with no remainder. You will always be left with no remainder in this step if you FOILed it out correctly to start and divided correctly to start. So if you did it right, you should end up with no remainder. If you have a remainder, then something went wrong. So another one of my factors is x plus 7. How do I find the other 0? Set it equal to 0. So x is equal to negative 7 is another solution. So I have x is equal to negative 7, negative 2 minus 5i, and negative 2 plus 5i. So those are my 3 answers. And I started with x cubed, so I know that I'm going to have 3 answers.